Come in, Eddie. We're back.
Yes.
Hey, use the restroom real quick.
Yes, y'all look taller, older. Oh my goodness. Are we gonna have anybody? We still have Candace, though, right?
James.
And James. Although I haven't had James. Oh, he was there yesterday. That's right. Orange wall behind me. Okay, if they ding dong on, I'll put another minute.
Might be just message. It's not good.
Oh, James has to come to his Spanish class, so he might be a little late.
Okay.
Stay person. Dry. I did not know that one. I think that was the only one that I didn't know. I was like, oh. And then I didn't know the word for after, but I knew the one was.
I put Ante too.
And I also didn't put the backside on there.
I know one brain switches to Latin kind of class.
What's that? And or
Post.
okay, put your
You got it right in your like Spanish.
Spanish. I just put post. I know it's Latin, but I didn't know that.
Yeah, I was thinking post.
I can't believe this. I was like, wait, what? I just like to think of that fallacy, the post air barrel or something. You know that one?
No,
It's like
I walked out all the way through here.
I don't know. There's a fallacy that has Latin. Before.
Post here goes no.
I don't know. It has it in there though. It's here. I'll look. I still have my fallacy books. I'll find it and I'll send it to you.
I took my Kelly's late.
No, I think I broke it.
I have all the most of my binders are replaced with books. So I have all my 10th grade stuff. I don't have one yet.
The only thing I remember about 8th grade is a scene that like weird back room. Like
Yeah,
little
messing
tiny room.
around.
Yeah, that's the only thing I remember from that year.
And that's when you worked out.
Really terrible choice.
That's the one where everybody left.
Yeah, that part was not there.
That was kind of hilarious.
Oh my gosh, I remember what
I remember when Levi broke down the boys' bathroom door.
I
Wrapped it in the
whacking
light
everyone with it.
He also posted tearing down the boys' back.
Oh, well, no, it wasn't us. It wasn't us. It was,
Oh, no, that was
some kid that used to
some kid named Levi.
Okay. Toss the blame. I see.
It's okay, I'm not here. He's not here anymore.
What happened this time? We know for nobody else but you. Huh? Okay. Was? What are y'all covering?
No idea.
Rational function.
Oh, yeah.
Are y'all like working on a homework assignment?
Are you all right?
Yes. The Candace and James.
It's Candace.
It's James not on it.
Did I do it right? I think I did. Hi.
Ah, what
She's
up,
connecting.
Candace?
She can't hear. She can hear you. Hello. I can't see my hand. There it is. Yes. What are you? Yes, the
I just wanted to see what it felt like.
Mrs. Welch is gonna walk in and we're all gonna be standing around her computer like this.
It'll be fine.
Y'all are contaminating the computer with your kid germs.
I
She
didn't
told
do
us
anything.
to
I
do
just do
it.
it.
This has like,
I'm
oh,
fine.
she's the president
She's
now.
the president.
This has like
What the?
no sensitivity to it.
President
Okay, that's
Gonzalez,
fine.
president.
I object to your president.
That's just kidding.
Wow,
Kidding,
that's
I'm
not
kidding.
how that works.
I'm kidding.
This looks so gross. I hate it.
No.
Yeah, me too.
Well, now you can't see.
No.
her.
What the?
even see
Wait,
face.
what's
Naruto.
that one? What's that one?
Stay at the same level.
Oh, she's.
I can't see the person. I don't know what
Jesse.
that is. What is happening? I have no idea.
Naruto.
Naruto. What the?
Oh.
She
It's an
has
angel.
wings.
No, it's a bird.
That's
what was it?
not-
Okay.
But it's like-
Unicorn.
Face
I haven't gotten a lot of backgrounds in recently, so I don't have much good stuff. Sorry, y'all.
You guys.
moves.
Yeah, but they-
What is happening?
I don't speak Spanish, you know, I
Yes,
Spanish
you-
food.
You obviously
in
used it,
Spanish
you
food.
recognized it as Spanish.
just came from.
You know what siéntate means.
Somehow it went to this little thing. And I really like having that table to myself. That's all right. I'm an opportunist. I have a podium. There's Candace. I can see her now. She can see us. Let's see, we are. $74. I want to get y'all to do some stuff on the board. Let's look at 2-6. 168. We've talked about finding the domain, the x-intercepts, the y-intercepts, the vertical and horizontal asymptotes. And did y'all? I think I did do that. Okay. I think I'm gonna 274. Okay, let me go over one. I don't know. No, I think I'm gonna let y'all jump right into it. So go to the whiteboard. And I will minimize. Actually, I'm gonna go shift. Okay, let's maximize the screen. And what I'm doing is we're going to look at the checkpoint. So write this down. F of x equals 1 over x plus 3. State the domain. This is a quick and easy one. X plus 3, that's not the domain.
Oh,
You use that to find the domain. Remember, you don't want the denominator to be 0. So basically, it's all the real numbers except -3, right? Because you don't, that's what you don't want. So all real numbers except x not equal to -3. Right, because you don't want -3 in the bottom. Could x be 0?
yeah.
Yeah, because if x was 0, what's y?
3.
No,
No, I mean -3.
no,
What? Oh.
1/3, right? Because
Wow.
right, because a 1 over,
Yeah.
right? Okay. All right, good job. Erase. And write this down. F of x equals 3 plus 2x over 1 plus x. So in this case, I want you to sketch the graph and state the domain. Okay, so here's what you're going to do with this. First thing is, what's the domain? That's going to be easy, right? Again, all real numbers except x can't equal what? -1, right? Because that would give you a 0. So on your xy axis, draw an xy axis. And where x is -1, do your dotted line. because that's also your vertical asymptote, right? That asymptote means that the function is never going to have a value along the x-axis. I mean, that vertical line. Okay, then what are we going to do? Let's find some intercepts. What did I just do? There it is. Let's find the y-intercept. Any idea what the y-intercept is? How do you find it? Isn't it just 3? Why? It is. Okay, and the formal way of doing it is set the numerator equal to 0. No, that's not what you do. You set x equal to 0. Yeah. So you do, and so 3 plus 2 times 0, and you end up with 3 equals y. So that's how you get the y-intercept. Or you just look at the constant coefficient, which is 3. And so we're going to go up to 3 on the y-axis and draw a dot on the axis, a big dot. You got the dot? Good job. Make it bigger as it looks like part of the line. I mean, make a real big fat dot. Okay. Everybody got visible dots? I'll be able to see it from a distance. There you go. Okay. Brian's is more of a spot. A spot's bigger than a dot, right? Okay, now what about the x-intercepts? How do you find the x-intercept? If it has one, you go ahead and set the numerator equal to 0. 3 plus 2x equals 0, and solve for x. And what did you get? Negative 3/2? Okay, so where is that on the x-axis? About 1.5. So let's put a big dot there. Okay. Then what else are we going to plot? The y-intercept, we did that. We did the vertical asymptotes. Okay, we're going to see if there's any horizontal asymptotes. Okay, so what are you going to compare to get the horizontal asymptotes? Ooh, this was, I had 2 number 1s on mine. Sorry about that. So I'm going to go to number 3 now. Yeah, you look at the exponent of the x's. And in this case, they're both 1, right? Both the exponents are 1. And so I'm going to write exponents are equal. And so that means that your horizontal asymptote is what? Is the coefficient in front of the x's, okay? Which in this case is a 2, in this case is a 1. And so it's 2 over 1. So is that x equal or y equals 2? It's a horizontal exponent, so it's going to go through the y-axis. And so it's y equals 2 is your horizontal axis. And so you'll go over and do a dotted line that cuts right through y equals 2 there. I think we might have actually did this one yesterday. Is this familiar? Yeah. Okay, so we've done the intercepts, the asymptotes. So now, in order to know what the function is going to look like, you just got to plug in a few more values, like make a little XY chart. X here, Y there. And pick some Y's to the left of your dots and a Y to the right of your dot. And see if you can figure out what X is going to be for some of those spots. Like this is 1 and 2. I'm going to pick 2 for my X. Can y'all see what I'm doing over there? Way in the corner. Right here.
Oh.
So if you put 2 into the original function, 7 over 3. Oh, that's ugly. We can do this one. 7 we'll put in 2/4, 7/3, yeah. Which is about 2 1/3, right? So 2, it's 1, 2. Oh, wait a minute. That doesn't look right. Oh, because I did 2 instead of -2. I meant to do -2. Okay, so 2 is 2 1/3, so it's way down here. And then -2 would be 3 minus 4 is -1, -1/3.
Oh.
Y'all get -1/3 for -2? It's -1/3, which would be about right here. Okay, anyway, you get enough of them and you're gonna see that your line's gonna kind of do this thing, right? Along, kind of like 1/x. Like that, kind of goes down. You get that kind of thing happening with these rational functions a lot. If you like, let me come over here.
Wait, so you did what they do.
Yes, plugging it in there. So like if x is -2, then that'd be -4, and 3,
You got one.
-1, and then 2 here, you get 3, so -1/3. -1,
But you put -1 here.
no, you're putting -2 here.
Well, it's negative for this one.
-2, oh, -2 plus 1 is -1. -1 and then -1. I'll put 2 there again. You're right. Okay, so what did I get? 1? Okay, so this was
That is
1.5.
this one.
And that's 2, -2, and they're negative. And so that would be 1, so you put a dot there. This is a fingernail polish from Hanson Eagle. Okay, so anyway, if you do enough of them, you're gonna see it. And this is your half touch, so it'll go up and get closer, and here it's gonna go up, and you get closer to this, and here, and go down, get closer, but never touch. Okay, that's actually the name of that kind of shape is a hyperbola. Everybody kind of got their hyperbola drawn out? Yeah, so I had a wrong value. Let me erase and put the right value. Brian straightened me out. When it's -2, your y value is 1. Is that what you said? Or yeah, 1. And so that makes it looks like it's in the horizontal. Yeah, so it's about right there. But you got the right idea. And you can do more points until you're sure, but I don't want to spend too much time. So everybody feel pretty confident about their graph? Drawing it in, maybe? Okay. All right, so let's erase and try another one. Okay, I'm going to clear all drawings. And let's do the checkpoint on page 173. Okay, here you're going to have f of x equals 3x over, and in parentheses, put x squared plus x minus 2. All right. So y'all work at it. See what you might have to look at your book at the steps. I'm not going to walk you through this one. See what you can do. Remember, you're finding intercepts and asymptotes. See what you can do. If you need the rules, I'll write down the rules and then have you do it. Okay. First thing we're going to do domain. No, how to do domain? Yeah, no, let's not do domain. Let's do, I'm going to follow the steps they have on page 171. Simplify if possible. How could you simplify? You could factor the denominator, right? Maybe it factors, who knows? We don't know for sure, but you can try it. Everybody factor it? Does it factor plus 2 and minus 1? Okay, looks like, okay, good. That'll come in handy in a minute. Okay, so now let's find the y-intercept. You remember how to do that? You're going to set the numerator equal to y and plug 0 in for x. So in this case, that's going to give you 3x equals 0. So what's x equal to? Yeah. In other words, it's going to go through the origin. Okay, so on your, you can just go, bloop, all right? Because that's where the y-axis is at 0 is right there on the x-axis. Okay, the third one is to find the x-intercepts. So in this case, yeah, I should spell this right. Set the numerator in x equal to 0 and solve for x. Okay, so we're gonna say, did I do that right? Plug in 0 for x. Okay, I did not do that right. I'm getting these mixed. You're still, it's gonna be the same thing because it is in the, let me do this better.
You draw.
I'm sorry. Y equals 3 times 0. Yeah, that's better. Y equals 0. Okay, and then here, okay, so that's, we're gonna do 3x equals 0, and then x equals 0. So y equals 0, x equals 0, we got the origin. So that really, those two steps gave us the same thing. We're crossing at the origin. Fourth step is asymptotes. And so you're gonna set the denominator equal to 0. So vertical asymptotes, that denominator, and I would do the factored part, equal to 0. So x plus 2, x minus 1 equals 0. So then you set each one separately equal to 0. Or you can do it in your head. And you get what? X equals -2, x equals 1. Can either of those cancel with the numerator? No, and so you're gonna have two asymptotes at -2 and at 1, two vertical asymptotes. So let's draw them in. And at 1, so I got 1 dot and 2 asymptotes. Five was finding the horizontal asymptote. So there you go back to the original function and look at the exponents of, and we call this exponent on the top one n. In this case, it's a 1, the little n. And the exponent on the denominator, we call that m, right? And we look at what n, is n bigger or smaller? N is smaller than m, right? Which means that y equals 0, or the x-axis is a horizontal asymptote. Horizontal asymptote equals x equals 0. No, I'm sorry, y equals 0, sorry. Erase that. Oh, I didn't erase it, I scratched it out. Okay, so it'd be nice if you could kind of draw a dotted line along the x-axis, but it's kind of hard to do that because you already got a line there, but that's going to tell you what you got going there. Okay, now we're to the point where we have to do some plotting points. So we need to pick a point on either side of our asymptotes, okay, and on either side of our origin. This was 1, that's 2. I'm gonna pick -3 and -1. And if you're good at putting things in the calculator, you could put that function in the calculator and then look at the table. And that'll tell you what the values are. Right here. If you want to do that, that's fine, or you could just plug it in and
Plug
figure
it
it
into
out.
the original. Right?
Original equation, either one.
Oh, okay.
I think I'd rather put it in my calculator. Under y equals, and go to the table. But you don't want to look at the graph, because we're trying to figure out what it looks like without looking at the graph. So y equals, you probably want to use parentheses. Put the numerator in parentheses, put the denominator in parentheses. Okay, so -3, it looks like -2.25. And -1 is 1.5. And I'm gonna try 2 is 1.5. -3 is over here. About there. -1 is 1.5. And 2 is at 1.5. Can you tell what it looks like?
Fractions.
Not really.
I looked at the graph. I mean, I still looked at the graph. And it was like, you need a lot of points.
Okay, yeah. So I'm gonna try 1/2, 0.5. So I can go to my table set and tell it to delta table at 0.5. And it tells me that at negative, wait, what did I say? At 0.5, do another XY over here. At 0.5, I got a -1.2. So that's right over here. -1, so about right there. And let's see what happens at 3. It's 0.9. So at 3, it's about like that. Oh, so I'm starting to get an idea. Let me do -2.5. Y'all getting any over there? Or are you just talking?
No.
I have no idea what I'm doing.
Are you even paying attention to what I'm doing?
Yes, you're going fast in your.
Yeah, okay, -2.5 is -4, it's way down here. There's the dot. Okay, so look what I've got over here on this. I've got my asymptote, I've got this here. That's gonna kind of tell me that, because we can't go over the asymptote, right? So it's probably gonna do this thing. And here, what's doing is it's asymptote, and then it starts it swoops through the axis, and then goes back down that way. Okay, and then over here, oh man, it kind of does. I don't have much space there. I'll change colors. I'll go to red to draw the lines. If you do enough of these, they start getting easier. You start kind of predicting where, kind of like it's supposed to go.
At this point, all you're doing
More like that.
is plugging in the next values to the left of this asymptote, plugging in the next values.
And then here,
Out there, plugging in the next values. So right of this asymptote, take your y value, and that gives you all these ordered pairs.
And if you look at the calculator, I'll show Candace what I got there. That's what it actually looked. Can you see that? So it's kind of the same idea. Yeah, that's, the plotting point is the least fun of the part to me. That's why I like using calculator to pick some things and then you can kind of figure it out. Then you're using the calculator, you might as well look at it, right? Wait, oh, this is an asymptote.
Oh, yeah, it is.
You can't cross those asymptotes. No man's land. So it's gonna have to kind of go this way to the top. The other way. Oh, Brian crossed the x-axis. Remember the x-axis is an asymptote over here. Now it's not in between these places, but here it's going to go off. What do you have?
No.
So the only x-intercept we had was the 0. So you did have a dot over here.
I had like 1.5.
Negative 2. Well, this is 2.
Negative 2 is like, no. There's negative 3, right?
Negative 3, yeah. I had negative 3
4.2.
was 2.25.
Scratch
The negative 3 was about 4.2. Way down here.
that. Negative 3 was 2.2.
Oh, negative 2.25.
Negative 2.5 was, wait, no.
Yeah, 4.
That was 2.5 was like.
Way down there.
That's 4.
Yeah.
3. Alright.
You could also make it
There's a
this
straight
way.
here. So
So
There you go. Yeah, that's it. Remember to touch that. Y'all ready to try another one? I think there was another one.
you don't even need to make it like this.
Yes.
If you know the x-axis is an asymptote and you've got these,
Yeah, I'm gonna clear this
you know
one.
it's either gonna do this or this, right? And so you need like 2 points to see if it's doing, you know, if you plug in this value, if it's positive or if it's negative. And then you know, okay, it's equal to this. Same thing on this side, if you plug in this point, it's either way up here, way up here. Because the way your asymptotes are, you know, it's, yeah, exactly. The only one where it gets tricky is the middle, and you've got to do it. You get the shape of the curvature. Yeah.
Yeah, I'm giving you all the tricks. But see, mine like to draw it exactly perfectly as if the calculator did it. And this kind of rough, you know,
That's why it's
they
called
call it corner of
sketching.
the napkin kind of thing.
Mhm.
That's not how it does
It's my favorite.
it. Yeah. Okay, so let's try this one.
Great.
F of x equals x squared minus 4 and x squared minus x minus 6 on the bottom. This is the checkpoint on the bottom of page 173. So let's factor. Do you notice the top is a difference of squares? That should be popping out to you by now. Difference of squares, that means it's going to do, if it's a squared minus b squared, you're going to have a plus b. So this would be x plus 2 and x minus 2, right? Squares, and then can you factor the bottom? Has to multiply to give you -6 and add to give you -1. So I'm thinking -6 plus 1. No,
3 and 2.
it's gonna be 3 and 2, you're right. -3 and +2.
Yep.
And so you notice, don't you, that x plus 2 is on the top and the bottom? That means that x equals -2 is not an asymptote, but a removable discontinuity. Let's go ahead and cancel it out and write just x minus 2 over x minus 3. And I'm going to write down that x equals -2 is a removable discontinuity. The one that you cancel out like that. But because of x minus 3
Plus
here,
zero.
x plus 3, I'm sorry, x equals 3. Undo. Okay, x equals +3 is a vertical asymptote. Right, because it doesn't cancel out, so you can never have a value there. So that's what when you factor it, it tells you the one on the bottom that can be removed by cancellation is a removable discontinuity, and the one that can't be removed or doesn't cancel out tells you what your vertical asymptote is. Okay, so we simplified. What about a y-intercept?
You're gonna do the math.
Remember how to get the y-intercept? Y equals x squared minus 4 and substitute 0 in for x.
So we've got a vertical asymptote at x equals 3.
So y-intercept, I can go ahead and put that on my calculator, on my graph. And 3 vertical asymptote. 1, 2, 3. Do, 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 do. The sound effects make it more fun. Do, 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 do. Okay. What about x-intercept? Remember how to do that? Okay, there you say 0 equals x squared minus 4. And you get x squared plus x equals plus or minus. So then when you have to take the square root of both sides, remember that you have to take the plus or minus square root. So we have 2 x-intercepts. One at +2, one at -2. Enough room there.
Yeah, I'm good, thank you.
Okay. How about horizontal asymptote? We're looking at our highest value of the exponent, which tells us that,
Wait, do you put the dots for the x-intercept? Right?
yes. You got it. They called it A over B, right? So in this case, our A over B is 1 over 1. And so y equals 1 is a horizontal asymptote. Well, this looks weird, doesn't it? Did you get your -2? Okay, so to get your x-intercepts, you set that equal to 0? Did you do that?
Yeah.
In your head, but the thing is that, okay, so x squared equals 4, so you take the square root, but it's also plus or minus the square root. So x equals plus and minus 2. Because -2 squared is 4. Yeah. So this is, what is that?
So, 1.
Okay, that's an asymptote.
Oh,
So it's gonna, yeah, the asymptotes are dotted lines. Intercepts are dots, asymptotes are dotted lines. Okay, I'll repeat that so Candace can hear. The intercepts are dots and the asymptotes are vertical or dotted lines. Okay, so dotted line, dotted line. Okay, so we could probably figure out what this is going to do already. Maybe not. I was thinking it's going to. Like, what can it do when it gets to that corner here?
Probably go down.
Go down, yeah. Well, let's try XY chart and put some points in. And in this case, I'm definitely using my calculator. I want to get a,
And we pick points from the,
like on either side of each point and between each point and asymptote, like lower than -2. So I'm going to do a -3. And then I'm going to do something in between here. I'm going to do -1. And then I'm going to do 1. And I know it's not going to do anything at 3. Let me see what it's doing at 4. I'm going to try these in these values. So you look at your x-axis and you look at what are some good points for there, in between these other interesting. Did you get a data chart? Don't look at the graph. Huh?
This is the correct.
Yeah, that looks good. Okay, yeah. So, where's that -4 come from? Or is it positive? What happened there? And so we said that at 0, it's, I say 2/3. Okay, I'm gonna do it on my calculator and see what happens. Okay, Brian's discovered we have some kind of problem here. According to his fancy calculator. X squared minus 4. Oops. Mr. Smith, do you see anything I might have done wrong so far? Entirely possible.
The points don't look like what the graph looks
I know, that's why. So what did I do wrong? That's what it looked. Okay, let me go to my.
We've got these 3 points, but there's
I think one is a horizontal, horizontal asymptote. And 1, 2 is a horizontal 2. I'll just see, I'm gonna have to zoom in.
So it looks like you've got we've got the vertical asymptote at 3. And the horizontal asymptote at 1.
Yeah,
But then the 3 points that we found.
3 points are bad.
Yeah.
Okay, so I'm going to give myself some room here.
It's really the y-intercept that's
Yeah,
messing us up. It should come. Well, even the -2 for the x-intercept, like it's not coming on the x-axis.
I know.
From that asymptote.
Okay, so let me go back to my thing here. It says, plot and find the y-intercept, if any, and it does have one, by evaluating f of 0. In other words, f of 0. And so maybe because you have to put 0 squared minus 4 over 0 squared minus 0 minus 6. So I guess you don't just use, see what I have here? You don't just use the numerator when you put 0 in for x. You have to put it in the denominator too. That's what I was doing wrong. I was just looking at that. But you got to do the denominator too. Because now you're going to get what? Yeah, -4/6 or +2/3. So erase some dots. Oh, dang it. Oh, man. Okay.
And that's for the y-intercept. So yeah, that's right.
Yeah, that is
That's
better.
right below that horizontal asymptote.
Right here. Okay, and then let's do the x-intercepts. It says numerator, setting the numerator equal to 0. So x squared minus 4 equals 0. X squared equals 4. That's weird. Find the zeros of the numerator by solving the equation, numerator equal to 0, then plot the corresponding x-intercepts.
The +2 is right. It's the -2 that I guess you would just have to think logically and reject it based on like the parent function and what it should look like.
So we have that there, but not -2. Okay, what about our y? Oh, that's what we did. We already fixed that. Okay, so and then if you do some more points, you get these up here real. Yeah, so I guess when it's just like that, that's about accurate. So we fixed this one and put it up here, and then this one doesn't. -2 doesn't count. Oh, 1, 2, 3. What's that line there? I think I did. Because that's 2. But then we also have some stuff over here. So you would have to actually plot some more points to this side over here. Yeah. What's the what? Oh, so that means at 2, we said 2 was a removable discontinuity? You said what?
You told us -2.
-2. Okay, that
Well,
means.
wouldn't that be x equals?
Okay, because of this right here, x plus 2 equals 0, so x equals -2. So you go over to, okay, so let's say we draw this like this, and we do our little lines. Well, then at -2, 1, 2, you had to have a circle right there. Because if you look on your data table, at -2, it says error. Okay, we'll practice some more again. Y'all are dismissed. It is lunchtime. Sorry for messing that one up for you. I don't really want to start doing homework yet still. We still got to do slant asymptotes. Then we'll be ready for homework. So tomorrow we'll get into that. So no homework yet. And I'm going to quit sharing. And all righty, Candace. So you got the other homework. I mean, I texted the last few problems that you had. So you're all done with 2.5. And I haven't ordered any or haven't assigned anything for 2.6 yet.
Do what?
So I will let you go. You're doing okay?
Yes, ma'am.
Well, then I'll see you later.
Yes, ma'am. Thank you.
Bye-bye.